Hello, we are mechatronic engineering students and we will explain a bit about the data transmission. Our team is made up of Edgar, Omar, Ramos, Santiago, Aryk, Maravilla, Hernández, Erick, Córdova, Vázquez, Jonathan, David, Solano, Cervantes. Introduction. Since ancient times, the human being has had the need to communicate and transmit information, which has evolved with technology to reach data transmission. Now we'll see what data transmission is and how it works. What is data transmission? Data transmission refers to the process of the transferring data between two or the more digital devices. Data is transmitted from one on device to another in analog or digital format. Basic data transmission enables the device or the component with the device to speak to other. How does data transmission work between digital devices? Data is transferred in the form of bits between two or more digital devices. There are the two methods used to transmit data between digital devices: serial transmission and parallel transmission. Serial data transmission sends data bits one after another over a single channel. Parallel data transmission sends multiple data bits in the same time over multiple channels. What is serial transmission? When data is sent or received using serial data transmission, the data bits are organized in a specific order, and since they can only be sent one after another, the order of the data bits is important. It is dictates how the transmission is organized. When it's the received is the viewed as a reliable data transmission method, because a data bit is only set if the previous data bit has already been with receiver.
Well, serial transmission has two classifications: asynchronous and synchronous. Asynchronous serial transmission is when data bits can be sent at any point in time. Stop bits and start bits are used between data bytes to synchronize the transmitter and receiver and to ensure that the data is transmitted correctly. The time between sending and receiving data bits is not constant, so gaps are used to provide time between transmission. The advantage of using an asynchronous method is that no synchronization is required between the transmitter and receiver device. An asynchronous serial transmission data bits is when data bits are transmitted as a continuous stream in time with a master clock. The data transmitter and receiver both operate using a synchronized clock frequency. Thereof, start bits, stop bits, and gaps are no use. This means that data moves faster and timing errors are less frequent because the transmitter and receiver time is synced. What is parallel transmission? When the data is used in parallel data transmission, multiple data bits are transmitted over multiple channels at the same time. This means that data can be sent much faster than using serial transmission.
Given that multiple bytes are sent over multiple channels at the same time, the order in which a bit stream is received can depend on various conditions, such as proximity to the data source, user location, and bandwidth appetite. Third example: of parallel interface can be seen below. In the first parallel interface, the data is sent and received in the correct order. In the second parallel interface, the data is sent the correct order, but some bytes were received fast time order. A byte data but sent, a byte data but received. Advantage and disadvantage of the using parallel on data transmission. The main advantage of parallel data transmission over serial transmission are: in the is easier the program and data is sent faster. At low parallel transmission can transfer data faster. It requires more transmission channels than the serial transmission. This means that bits can be used of sinks dependent of transfer distance and whole file each bit loads. A simple example of the where this can be seen is with a voice over IP. Can with distortion of interface is noticeable. It can also be seen when there is skipping of interface and video stream. When is parallel transmission use the same data? Parallel transmission is used when a large amount of data is being sent. The data being sent time receive time, and the data need to be sent quickly. As necessary with all parallel transmission is used to send data is video streaming, when all video streaming to view bits need to be received quickly to prevent all video pushing. All viewing video streaming also requires the transmission of large volumes of data. The data being sent also time sent received, as also data stream result in peer-view experience.
As a continuation, we have that is the parity bit. Parity bit is found in digital data since transmission systems. An error occurs when a bit is altered between transmission and reception. For these cases, there are algorithms that detect these types of errors, one of them parity bit. There are many sources of error in the form of different types of noise, such as EM noise or thermal noise. As we know, the parity bit is a parameter with a value of 0 or 1 that is used in a transmission error detecting method in which a 0 or a 1 is added to each group of 7 to 8 bits. The aim is that this way each byte always has an odd total quantity of 1 or an even total quantity of 1 according to the established parity. We should also know that we use two types. Two types of parity are used. Even parity, where a parity 1 bit is added if there is an odd total number of bits 1 in the previous byte. An odd parity, where the opposite is done. With this method, you can only know that an error has occurred, but you will not know where the error occurred. And as a continuation, we have a small example, and the example is a company wants to communicate with its main branch located in the center. A message is sent in which an encrypted password is attached by its primary modem. Upon receiving the message at the branch, the recipient of must detect failures in the message. The received message was the following: That example is 11010111. The receiver knows that the message sent is of an odd parity. Since it only detects errors, it's intended to know the error of message. Well, on the right we have the message received with error, and it's with the what is the correction. As we know, the message sent was of parity. As we know, an odd parity message must have arrived, but uneven parity message arrived. From that, we know the comes with an error. And well, we have a conclusion. In conclusion, you know that the data transmitter facilitates communications between 2 points. For this type of communication, it's important to have a good telecommunication infrastructure to be able to send and receive transmissions of the message successfully. Likewise, it will have an algorithm that will be capable of from detecting faults and some occasions even correcting them. These faults are caused by noise, caused by various factors that intervene in this signal or the signals.